physics class. My name remains Ojoba Hyginus. Today we are continuing from where we stopped. You know, in the last class we discussed electric field as an example of vector field, and we mentioned so many things. We introduced electric field, we defined terms related to electric field, where we defined current, defined voltage, we defined potential difference, EMF, and all that, even charges. Now, we are going to look at how this electricity is being produced, how this electric current is being produced, because you cannot be talking of charges, current, voltage, potential difference, EMF, as we define it and even give formulas without knowing how this thing come about. If you go to your home appliances, for instance, your torchlight have a source of electricity, which might be battery, might be a Tiger battery like you commonly use, or a rechargeable battery. Your phone is being powered by battery. Your light in the house is either powered by a generator or the country's generating station. Now, all these electricity that I have mentioned are not coming from the same source, but all of them produce electricity. All of them produce electricity. So we are going to look at the various means of production of this electric current that we are using in our everyday life, and the principle, how do they work. Now, we know that in our first time we defined energy, that we gave the law of conservation of energy, which was stated that energy can neither be created nor destroyed in a closed system, but can only be converted from one form to another. That means that for electrical energy to be formed, which is a form of energy that gives us current and voltage, for such energy to exist, there must be a source. There must be another energy that is being converted to electrical energy. It doesn't just come that way. So we are going to look at these four sources of electric current. We have chemical energy, heat energy, mechanical energy, and solar energy. Then, how do we generate electricity from chemical energy? Chemical energy, when you talk of chemical energy, is production of electricity through chemical reactions. Through chemical reaction, when elements react with another element, the result becomes current. And then we say that this electricity is produced from chemical energy. Now, a simplest example we can give of this chemical energy source of electricity is a simple cell. A simple cell which we can also call a voltaic cell. We call it a voltaic cell because it was formed by Volta. A simple cell consists of two dissimilar metals. That is, two metals that are not the same, dipped into a salt or acid solution. Two dissimilar metals dipped into a salt or acid solution forms a simple cell, and that can generate electricity through the reaction of these two metals and these salt or acid solution. Now, in a simple cell, generally we don't just use any two metals, because we are now commonly using two metals known as zinc and copper. Now, let's give a simple diagram of a simple cell, which we call a voltaic cell. We have two metals. We said one is copper and the other is zinc, dipped inside a salt solution. For a simple cell, we make use of sulfuric acid, that is H2SO4, as the salt or as the acid. Then these two metals, copper is known as the positive electrode, zinc is known as the negative electrode. When you see this, it's negative. When you see this, it stands for positive. Copper is the positive electrode. These two are called electrode, while the acid or salt solution is called electrolyte. This is electrode and this is electrolyte. So this is positive electrode, this is negative electrode dipped into sulfuric acid. A simple or common one, or a simple cell we can get in our home, is getting two dissimilar metal and dipping them into unripe orange. Unripe orange will produce this acid that is needed as the electrolyte. So when that happens, this is a simple cell. But how does this generate electricity? How does this simple cell generate electricity? As it is like this, it is expected to be dormant, because there is nothing that is igniting it. There is nothing that is making it to start producing electricity. It can only happen if we now connect, if we now connect these two electrodes with the use of a conductor and with the help of a load, let's say a lantern or whatever that will consume the electricity, connecting these two electrodes. Now, when it is connected, what happens is that immediately you connect the two electrodes using a load, the zinc electrode will react with the sulfuric acid to release hydrogen bubbles. And when that happens, the zinc will now be able to produce electrons that will now flow from zinc to the copper electrode. And as electron is flowing from zinc to the copper electrode, it will now ignite current to now flow in the opposite or reverse direction. Current will now flow in the reverse direction from positive to negative. That means electron flows from negative to positive, while current flows from positive to negative. So long as this conductor is connecting these two electrodes together, there will be current flowing as a result of electron flowing in the reverse direction. So that is a simple explanation of a chemical method of producing electrical energy. But there is problem with this type of cell. There is problem because these days we don't use simple cell again because there are advancements. So we have Daniel cell, Leclerc cell, and even accumulators. And those advanced ones are used to overcome the problem or the challenges of a simple cell. We are going to look at two defects or challenges. Two defects or challenges of a simple cell. Two defects or challenges of a simple cell. A simple cell has issues. One of the issues is that when this circuit is being connected, the hydrogen bubbles that are being released when zinc electrode reacts with the sulfuric acid, the hydrogen bubbles that are being released will go and cling itself to the copper electrode. And what happens? The hydrogen bubble now serves as a positive electrode instead of copper. Remember we said that it's copper that will react with the zinc. The copper is positive electrode while the zinc is negative electrode. But now, if the hydrogen bubbles are produced and attaches itself to the copper electrode, these hydrogen bubbles now serve as the positive electrode reacting with zinc. And when that happens, it produces a cell. It produces what we call a back EMF. Because the current that will be produced or the EMF that will be formed when the bubbles of hydrogen serving as the positive electrode reacting with zinc will now be moving in opposite direction to the current moving in the external circuit. And when it is moving in opposite direction, it is opposing the original current in the external circuit. And because of that, there will be wasted energy. Because the current in the external circuit will try to overcome the current formed between the hydrogen bubbles and the zinc electrode. And this process is what we call polarization. The process where the hydrogen bubbles formed when zinc reacts with sulfuric acid and the hydrogen bubbles serve as the positive electrode to react with the zinc electrode to form a back EMF. This back EMF formed in this process is what we call polarization. And there is a way we can correct it. Polarization, I said, is one of the defects. Polarization is one of the defects of simple cell. How can we correct this? How do they correct it in the advanced cell? In correcting this, since we know that it is this hydrogen bubble that is causing this problem, and there is no way we can do away with hydrogen bubbles if zinc reacts with sulfuric acid, definitely it will release hydrogen, which will now come and cling and form a positive electrode. So how do we do away with these hydrogen bubbles? Impurities, to do away with these hydrogen bubbles, a chemical that we call a depolarizer is being added to this cell. A chemical we call a depolarizer. Example of such chemical, we have manganese dioxide, we have potassium dichromate, and so many other chemicals that will be able to do away with this hydrogen. How does it do away with the hydrogen? When I add manganese dioxide to a simple cell, it will oxidize the hydrogen. That is, when zinc reacts with sulfuric acid and release hydrogen, the hydrogen will be oxidized by manganese dioxide so that it will form water. Instead of it being hydrogen as a positive electrode, it will now turn into water and will no longer have effect on zinc. So in that case, we have depolarized depolarizer. We have depolarized it using a suitable chemical. This chemical is known as the depolarizer, and the method of preventing polarization is known as depolarization. Another defect of a simple cell is what we call local action. Local action. And what do you mean by local action? Now, a zinc electrode contains impurities. There are impurities in this zinc electrode, and these impurities react with the acid. When the impurities react with the acid, impurities like iron, carbon, will react with the acid. And when it happens, it will form tiny, tiny cells inside the circuit. It will form tiny cells inside the circuit. And this cell, in turn, will form a circuit inside this cell. And that circuit will be working, even when this thing is not connected. Even when there is no load. Because I told you initially that if there is no load, there shouldn't be a chemical reaction. But because of the impurities in the zinc electrode, there will be what? A cell inside a circuit inside the cell that will be working and will be using the zinc, even when the cell is not in use. So that after a long time, you bought the cell and you have not used it, after a long time, it will be gone because the zinc is being consumed and you can no longer use it. So in order to prevent local action, this process is what we call local action. When tiny cells have been formed inside the main cell to consume the electrodes even when the cell is dormant. So how do you prevent local action? We prevent local action by the process we call amalgamation. Amalgamation. And what is amalgamation? Amalgamation is the process of preventing these impurities in the zinc from having direct contact with the sulfuric acid. How do we do that since the zinc is deep into the acid? How do we prevent the impurities of the zinc from having contact with the sulfuric acid? Of course, we cannot do away with the impurities. They are there with the zinc. So how do we prevent it from having direct contact with the sulfuric acid? We can do that by rubbing this zinc electrode with something that will prevent it from having direct contact. An example of such is what? The mercury. You can rub the zinc electrode or dip it into a mercury. The mercury will prevent a direct contact of the zinc with sulfuric acid. And I said that the process of preventing local action is what? Amalgamation. So you can see how we are able to overcome these challenges of a simple cell. But we know now that this is the method of producing electrical energy through chemical method, the use of cell. Another method of production of electrical energy is heat energy. Heat energy. How do we produce electrical energy through heat? How do we produce electrical energy through heat energy? Electrical energy can be produced through heat using two dissimilar metals. Two dissimilar metals such as we can use, let's say we can use cold junction. We call this place cold junction. We call this place, let's say we have a candle here. We call this place hot junction. And then what we have here is ice, and what we have here is a burning fire. Now, heat, electricity can be produced through heat when you bring two dissimilar metals. Let's say this one is iron and this one is copper. You connect them at the two ends and then subject the two ends to different temperatures. It must not be this type of connection. If it is in a cold environment, you might not even need ice. Just put one end in a hot water or make it to be hot. The other end is already cold. But in a normal temperature, you can make one end to be cold and the other to be hot, so that there will be difference in temperature. When there is difference in temperature between these two dissimilar metals, electricity is being produced, current is being produced. But the issue is that the current produced here is very minimal. They are insignificant. And that is why you see G here. This is galvanometer. this sign is representing galvanometer. And you can remember that when we were discussing about the instruments used to measure current, we said conventionally we use ammeter to measure current. But there are some currents that ammeter cannot measure because of their small magnitude. And because of that, we use mini galvanometer to be able to determine this insignificant current that is being produced. So this is another method of producing electricity through heat. This is the method of producing electricity through heat. We are going to look at the third method, which is through mechanical energy. Electrical energy from mechanical energy. Electrical energy from mechanical energy. One of these methods is your generator or hydropower station, like the one we use in our country where we use water to generate electricity, is under mechanical. Now let's look at what happens in our generator. The simplest or the easiest method of generating electricity through mechanical energy. Mechanical has to do with movement of objects. So the simplest way is through the use of bar magnets. When we have two bar magnets placed in their opposite polarities. We have two bar magnets. Let's say this one is north and this one is south, for instance. They have opposite polarities. And then an insulated conductor placed in between there. Of course, this bar magnet will produce magnetic field here. It will produce magnetic field. Remember what we define magnetic field to be. And then we have a mechanical drive here. A mechanical drive, that is something that will move this conductor around, that will rotate it. A mechanical drive here. Now, when this happens, when you place an insulated conductor in between the field of two bar magnets and make this conductor to move, to be in motion. Remember I said it's mechanical. Mechanical has to do with motion. So if this conductor is in motion, current will be generated. Current will begin to flow around the conductor. And that is what happens in our generator. That is why you see some lifters, you have to turn the turbine, you have to turn it for a very long time before it produces current. Or the normal Tiger generator that will have to draw the starter and it will have to generate electricity and we use it. So how do we have this electricity? We can use a slip ring or a split ring, whichever, but one is for direct current, one is for alternating current. Direct current is a current that flows in one direction, that is from positive to negative. But alternating is the one that changes polarity. It will be positive in 1 minute, one polarity will be positive in 1 minute and will be negative in another minute. Like the one we use from our socket is alternating current. Because you can plug your socket, you can plug your extension or whatever in either direction, you still receive current. It is alternating. But if you're using a battery, you cannot change the polarity. If you change the polarity, it will not flow because the battery is what? Direct. So let's use let's say a slip ring. A slip ring. One end is connected to the positive, is connected to one slip ring, and the other to the other. Then from here, a carbon brush is being attached to it. The carbon brush is made to touch it. Then from the carbon brush, we'll now connect our load. Which can be a lantern or whatever that we use the electricity. So this is the mechanical method of producing electricity. When this conductor is being turned in this field, current flows and we're able to supply current to this. That is a mechanical method of producing electricity. And it's an electromagnetic method because it is a combination of magnetic field and motion of conductor to produce electricity. It is electromagnetic. Another method is through the use of water, like I said, which is hydropower. And in hydropower, you know, in Nigeria we have some hydropower stations like one in Kenji, one in Jeba, and one in Shiroro. These are hydropowers that produce electricity in large quantity that we use. Now, how does it do? How does that happen? At times we say, how can water be producing electricity? It's not as if water is producing electricity, but water is serving as a drive. Unlike in this case that some mechanical drive is attached here, or you use your hand to turn it. In hydropower, instead of hand, because of the quantity of the quantity of electricity that is needed, hand will not be able to turn the turbine that will produce such electricity. So a dam is being created. A dam is being created close to a river. Hydropower cannot be formed in a place there is no water. So it is always formed close to a river. A dam is formed where this water flowing in the river is being stored in the dam. That is a closed wall where you store the water, so that you'll be able to regulate the movement of the water, because you cannot regulate the movement of water in the river. So because of that, we create a dam and then store this water such that we create small opening in the dam that will be able to do what? To move with a great force. And when this water moves with a great force, it now touches. The water will now go and derive or move the turbine. And the turbine is connected to a dynamo, which is the device that will now produce this electricity. The turbine is connected to the dynamo using what? A blade, a fan blade. So that when the turbine is turning, the dynamo as well is turning. And as the dynamo is turning, electricity is being generated and being distributed to consumers. So these are examples of mechanical method of generating electricity. So finally, we look at solar energy. Electricity can also be produced from solar energy. When you hear solar, it has to do with sun. It has to do with sun. When electricity is gotten from the sun, it is solar. In this case, a panel is being produced, or a photocell, something that will be able to attract the sunlight. And when it attracts the sunlight, it converts this sun energy or this light from the sun into electricity. And you can see a typical example of such, the sunlight resting into this panel, where you have a metal cathode, which is the negative electrode, and an anode, which is the positive electrode. So when sun is brought to this, the light is being transferred through this medium. It's being converted to electricity and is being stored in this cell. In photocells, it's being stored in photocell, which you can use as a direct current, or we can as well use something like an inverter to convert it to alternating current to use. You can see a microammeter can be used to detect the current produced when the sunlight falls on the tube. When the sunlight falls on the tube. So this is a method of generating electricity through sunlight. We use it these days. So many homes use it in a smaller size, such that as an alternative form of electricity, when the country's distribution company takes up the light, you can use your solar, you can use your generator, which is a mechanical method, and you can use a battery. Some use batteries connected together and an inverter to convert it to AC. That is what? Chemical method of energy. So we can even convert from one energy to another. We can convert from one energy to another, as you can see, to produce electricity. So this is where we are going to stop for now. In our next class, we go further still on electrical energy. We now discuss circuits. We look at how circuits, different types of circuits we have and things related to them. Do well to read your notes that will be attached, copy and read. Then go further in your textbook to have an advanced study of what we have discussed. Thank you and stay safe.